This is me, Timothy, doing my bonus project for 1011. So the goal of this project is to take button inputs and translate it into Morse code, and then decode it into text to display on the OLED. And for the setup, we just have the Arduino with the button and the display connected to the computer running the program.
The technical requirements of the system is to mainly detect button state and inputs, and then convert these sequences of button inputs to dots, dashes, and spaces to Morse code. Then it will convert the Morse code and translate it into text. And then finally it will display the translated information to the OLED display. So here, we have a graph that demonstrates how the program uses the input sequences to be translated into Morse code that the program can read and eventually translate. So focusing on figure 1 here, the figure represents the user communicating a signal, which in this case is a dash, to the program. To translate the inputs into Morse code, the first step is to check if there was a previous input. If there was a previous input, the time since the last input will determine the space between signals. This is because, following the International Morse code standards, if the time since the last input was 1 unit, then the new signal will belong to the same letter. If it was 3 units, the new signal will belong to a new letter, and if it was 7, it will belong to a new word. And then, the next step is to simply read the time held of the button, and it will determine if it was a dot or a dash. Then, it will add the outcome to a vector variable list, 0 being a dot and 1 being a dash. Now for the algorithm of the system, we start off by initializing the seconds for 1 unit of Morse code. And we also initialize the error margin for this unit because we can't click perfectly. We start off the loop by, if the system is done doing what it needs to do, then the loop will stop. If not, if the button is being pressed, but the button wasn't already being pressed, that means this is a new signal. If the button isn't being pressed, but the button was already being pressed, then this means the button was just let go, and we can calculate how long the button was being pressed for. If the button wasn't being pressed, and it wasn't already being pressed before that, that means the user has let go of the button for a while now. So we can calculate how many seconds was from the last input. If the seconds since the last input was over 10 units of time, we assume the message is finished. So we display the decoded sequence on the OLED display, and we stop the loop. If the seconds since the last input was 7, that means that's the end of the word, so we add a space to the current decoded sequence. If not, if the seconds since the last input was 3 units, then that means it's the end of the letter. So we translate the current Morse code sequence to the character, and then we add it to the list. Otherwise, if the seconds since the last input is 1 unit, that means the signal belongs to the letter. So it's either a dot or a dash. So if the button press length is smaller than 1 unit, that means it was a dot, and we add it to the current sequence. Otherwise, that means it was a dash, and we add it to the current sequence. And that's when the loop repeats, and I'll update the live graph.
So the Arduino is running code on the Arduino environment and basically uses libraries to manipulate the display. Here's an example using SOS as the message. I definitely believe this project is holistic because we can take physical inputs to be translated digitally, and this could be useful in real-world communication. So in conclusion, my project definitely succeeded in converting inputs into Morse code and decoding it into text.